Question 2. This question is about period 3 of the periodic table. So in period 3, they've all got 3 electron shells. All the atoms have got 3 electron shells. So they've got the same number of shells, therefore shielding doesn't come into it. Deduce which of Na1 plus and Mg2 plus is the smaller ion. Well, let's go back to our periodic table. So Na is here with 11 electrons and 11 protons. If it loses 1 electron and becomes Na plus, it loses 11 electrons. 1 is lost and it becomes 10. So Na1 plus loses one of those 11 electrons and it gets 10 electrons. Still got the 11 protons, just gets 10 electrons. Mg2 plus, 12 protons and 12 electrons. If it becomes Mg2 plus, it loses 2 electrons and gets 10 electrons. In other words, they both can have the same number of electrons. Na1 plus loses 1 electron to become 10 electrons. Mg2 plus loses 2 electrons to become 10 electrons. They've both got the same number of shells, 3 shells, same amount of shielding. The only difference is Mg has got 12 protons still. Remember, protons are unaffected when it becomes an Mg2 plus. And Na has got 11 protons, still got 11 protons when it becomes an Na plus. So, which one's going to have the greater nuclear charge? Mg's got 12 protons, greater nuclear charge, greater nuclear attraction for the electrons that it has, same number of electrons, same amount of shielding, greater nuclear attraction. That Mg2 plus is going to be smaller than Na plus. Write an equation to represent the process that occurs when the first ionization energy for sodium is measured. Remember, ionization energies, the atoms are as gases, so Na is a gas. First ionization energy is the first electron removed, so it hasn't got any electrons removed here. It becomes Na1 plus, because it's had 1 electron removed, first ionization energy, still a gas, and the electron is shown as being removed as an E minus. The first ionization energy of some period 3 elements are shown in figure 1. So we've got sodium, magnesium, aluminium, silicon, phosphorus, sulfur isn't shown, we've got chlorine and argon. In theory they should all go up, so they should go up and each should increase. There's a couple of blips in there and we'll talk about a couple of blips, but they should all go up because they've got the same number of shells, 3 shells, same amount of shielding. It's just every time you go across the period you get one more proton, increased nuclear charge, increased nuclear attraction, greater attraction for the electrons, and therefore the ionization energy increases. The energy to remove those electrons increases due to the greater number of protons and the nuclear charge. So this goes up, so it's going to go up somewhere here. Interest in magnesium comes down, and we'll talk about that in a minute, but it goes up. So we're looking at magnesium coming up somewhere here because it's got 12 electrons rather than 11 electrons. Magnesium's got more electrons than sodium, so it's got a greater nuclear charge, and therefore it's going to require more energy to remove that electron. In this sort of region here, interestingly, it's higher than aluminium. Aluminium comes down because this has got 3 s2 electrons, this has got a 3p1 electron. So s2 electrons, 3 s2 electrons are more difficult to remove than a 3p1 electron. So a 3p1 electron is more easily removed. And so magnesium comes down here. Let's have a look at sulfur then. Sulfur is in this region. It comes down. The reason that sulfur comes down is that this has got 3p3. So phosphorus has got 3p3. Magnesium, aluminium 3p1, silicon 3p2, 3p3. The 3p3, it's half full, and the 3 electrons are not paired. In sulfur, you've got 3p4, so you've got 3 single p electrons, and you've got a pair, so 3 single p electrons, and the 4th electron pairs up with one of those 3p electrons. So you've got a pair of electrons and they start to repel. So that 4th electron, it has to pair up with one of the other 3 single 3p electrons, and that pair repels, and that's why it's easier to remove the 4th p electron from sulfur than it is from phosphorus that's got 3 unpaired p electrons.